What are common performance bottlenecks in big data systems? Imagine trying to have a conversation in a crowded room where everyone is talking at once. That's similar to what happens in big data systems when certain parts slow everything down. When working with large amounts of data, some processes can become the bottleneck that limits how fast the system works. These slowdowns can affect everything from cybersecurity defenses to data analysis results. Let's look at what causes these delays and how they impact the whole system. One of the main issues is data ingestion. This is when data is collected from different sources and brought into the system. If the network connection is slow or the data pipelines are not optimized, data can pile up and cause delays. For example, if a company is collecting real-time data from thousands of sensors, slow data flow can mean missing important events or delays in response. High-velocity data streams need fast, scalable ingestion tools to keep up. Next, storage and disk input-output speed can also slow things down. Big data systems store massive amounts of information on disks. Traditional hard drives are slower than solid-state drives, which can cause delays when reading or writing data. If storage isn't set up properly across multiple disks or servers, it can create a bottleneck, making data retrieval slow and affecting analytics or cybersecurity monitoring. Network limitations are another common issue. Big data systems often run across many servers or nodes that need to share data quickly. If the network connection between these nodes is slow or unstable, data transfer slows down. This can cause delays in data synchronization, real-time analytics, or threat detection, especially in large distributed environments. Processing power also plays a role. When a system has to perform complex calculations or run machine learning models on large datasets, the CPU can become overwhelmed. If the processor is busy handling many tasks at once, it slows down the entire process. This is especially true when running resource-intensive analytics or security algorithms that need quick responses. Memory is another factor. If a system doesn't have enough RAM or random access memory, it has to swap data to the disk, which is much slower. Big data frameworks like Apache Spark relying heavily on in-memory processing. When memory is limited, tasks take longer, and overall system performance drops. Databases and query performance can also cause delays. When users run complex queries on large datasets, poorly optimized queries or missing indexes can make responses sluggish. This impacts analytics and security investigations that depend on fast data retrieval. Software configuration and algorithms matter too. Outdated software or default settings in distributed systems might not handle peak loads well. Inefficient algorithms can also slow down processing, making the system less responsive during busy times. Finally, managing multiple tasks at once requires good thread and process management. If a system cannot handle many user requests or parallel jobs efficiently, it results in delays and lower throughput. This is especially important in real-time analytics or multi-user environments where quick responses are needed. Addressing these bottlenecks involves optimizing data pipelines, upgrading storage solutions, improving network infrastructure, and tuning software settings. Regular monitoring helps catch issues early, so resources can be adjusted before delays become a problem. Improving these areas keeps big data systems running smoothly, supporting faster cybersecurity responses and more accurate data analysis.